Linked list. Students, love linked list. Linked list is a linear data structure that contains a sequence of elements. Each element links to next element in the sequence. Each element in the linked list is called a node. Every node contains two fields, data fields and the next field. The data field is used to store the actual value of the node. The next field is used to store the address of the next node in the sequence. Reference to the next node. The graphical representation of the node in the linked list. Data link. Store actual values. Data field. Okay. Data field. We can store the required information. It can be any data type like integer, character, float, double, structure type. Example, age, character name. For example, reference data, reference part, it will hold the address of the next node. The address of the first node is always stored in a reference node known as friend or also known as, it is also known as header. Always the next part, reference part of the last node must be a null. Reference to the next node, it will hold the next node's address. Head node, last node, starting node at the linked list, node with a reference pointer as null. Okay, the graphical representation of the node in the simple list. Front, header, this is one, and the address of this one pointing here, and the address of pointing here. This is the basic node. Okay, and then last node will be the null. You see here example, address connected here. A linked list is a kind of a linear data structure in which data is stored in the non-contiguous memory locations. It is a type of linked list which is traversing occurs only in one direction from the head to end. A single list can be traversing one direction. See this, the head of the list. Okay, here will be there, and this will be pointing the head of the node, and 200 will point here, 300 last node will be there. Every node points to the next node. The last node in the is a pointer to null for the end of the list, and the head is pointing to the first node. Simple English node syntax in C program. Struct node int data, struct node star next. Struct node star head equal to null, where data is used to store the integer of the integer informations. Struct node next is used to store the is used to refer the next node. It will hold the address of the node. Data and reference, data and the next. The about declaration, the first node will store the data of the node and the second field will store the address of the next node. The basic linked list operations are traversal. Okay, traversals access the nodes to the list. Insertions adds a node to a existing linked list. Deletions removes a node from the existing linked list. Search find a particular element in the linked list. Sort the nodes in the linked list. Traverse. Accessing the nodes of the linked list in order to process is called a traversing or recognition. Normally, you use the traverse operation to display the content of the search for the elements in the linked list. The algorithm for traversing a linked list is given below. Traversing a single list is the following list. Take on temporary node type of type .temp and point to the head node. Start iterating using temp until it does not reach the null value. Print the data of the node when pointing by the temp node. Traversal. Step 1. Initialize. Set PTR equal to head. This is the temporary node. Okay, repeat steps 3 and 4. And while PTR not equal to null, PTR not equal to null. Okay, then apply process PTR.data and set PTR equal to PTR next. End of the loop. Okay, exit. So this step will continue for traversing. We first initialize the PTR with the address of the head. Now the PTR points to the first node of the linked list. A while loop is executed and the operation is continued until the PTR reaches the last node. Apply the process to display the current node. Move to the next node by making the value of PTR to the address of the next node. Inserting elements to the linked list. We will see how a new node can be added to the existing linked list in the following cases. The new node is inserted at the beginning. The new node is inserted at the end. The new node is inserted after the given node. Inserted. node, insert a node at the beginning of the linked list. There are two steps to insert the node at the beginning. Update the next pointer of the new node to the head node. Update the next point of the new node to the head node. Update the head pointer to the new node. Update the head pointer to the new node. Example, let us insert a node with 10, data 10 at the beginning of the given list. See this? Beginning of the list. Updating the next of the new node to the head node. Updating the next of the new node to the head node. Now, updating the head pointer to the new node. Update to this is inserting. So, this is my actual linked list. And this updating, I need to update this my 100 to here. Okay. And see this 900, my head will be the 900. This is the initial node. Updating the head pointer to the new node. Understood? This is my list. This 100 and this 100 is nothing but here start of already existing linked list. The new node is added. Now I need to update this 900 to here, and this will be, you have to point from here to here. That's it. Now this is pointed and the 900 is updated. The new node updating the head pointer to the new node. After algorithm for inserting at the beginning, if while equal to null, write overflow. If we are not able to add, then it's called overflow. Go to the step 7 exist. End of if. If that new node equal to avail. Okay, new node equal to avail means new node created. Avail equal to avail next. You have to point to the next. New node hyphen data equal to value. New node hyphen next equal to head. Head we need to point to here. Avail. What is avail? Okay. Insert a node at the end of the linked list. To insert a node at the end of the linked list, we have to take the following two steps. Traverse the list to the last node. Update the next pointer to the last node or to the new node. Example, inserting a new node with the data 88. See this? This is my start of the node, 100 here for head pointer. Then this is the new node, 300. Okay. 300 will go out here and a temp pointer will be 300. Now we need to, what is called, this is current one. Temp pointer is traverse to this one. Traveling the list and reach the last node. With the temp pointer, I have reached last node. Now this, what is called, update the next of the temp to the new node. Here is the new node. It is the new node. Okay. Now this will move here. Okay. So new node added, and the 400 will be pointed to here. Next. At the if avail equal to null, at the insert at the end, if overwrite or overwrite or write overflow, go to step 10. Else set new node equal to avail. Set avail equal to avail hyphen pointer next. New node hyphen data, that is pointer data equal to value. New node next equal to null. We have to assign the null value to the new node. That set PTR equal to PTR assigned to head. Head will be assigned to the PTR. PTR go to the next and the PTR set. Repeat step 8. PTR equal to PTR next. So you have to PTR means is a temporary node. I have to process until the last. Then PTR next equal to new node. That's it. Exit. Insert a node after the given between two nodes in a linked list. Insertion of a new node at the middle of the list needs the following steps. Traverse to the list till given position using temp pointer and move another pointer previous to its just previous node. Update the next pointer of the previous node to the new node. Change the next node of the new node to the temp node. Inserting a new node with 34 at a position 3 in the given list. For example, see this. I have head pointer and I have previous pointer and I have temp pointer. Okay. Traverse the list and reach at the given position. Reach at the given position. Traverse a list and reach at the given position. So it's a traversing. Okay. Now what we need to insert 34 at a position 3. 0, 1, 2, 3. Okay, here I need to insert 0, 1, 3. 3 before that I need to insert. Okay. So 34 I need to insert. Update the next of the previous to the new node. Update the next of the previous node. Then update the next of the new node to the temp node. Temp node we need to point to here. Okay, so insert after of elements, if avail equal to null, write overflow. Go to step 12. Okay, step 12. Go to step 12. Now set new node equal to avail. Avail, set avail equal to avail next. Set new node equal to new node pointer data equal to value. PTR equal to header. Previous pointer equal to PTR. Repeat step 8 and 9. Repeat step 8 and 9. While PTR data data and PTR pointer data not equal to num. Okay, this num is not equal to num. Now PTR, pre-PTR equal to be assigned to PTR. PTR equal to PTR next. It is repeating step 8 and 9 until reaching this particular values 34. 34 at the position 3. Okay. Until reaching the positions. Okay. Now where we are until reaching the positions. Now PTR next equal to new node. Set new node equal to new node pointer next equal to PTR exists. Deleting elements from a linked list. A node can be deleted from a linked list in the following cases. The first node is deleted, the last node is deleted, the node after a given node is deleted. Delete node from the beginning of the linked list. To delete the node from the beginning of the list, we have taken the following steps. Store the head node to any other temporary pointer. Move the head to its next node. Free the memory of the temporary pointer. So first deleting the node from the beginning in the given list. Step 1. Store the head node. Store the head node to the temp and move head to its next node. Okay, now this head node is set a head will be there. Move the head to the next node. Free the memory of the temp node. Throw it out. This one. Okay. Algorithm. Delete from beginning. If head equal to null, write underflow. No record is there. Okay. No what is called no node is there. And if set PTR equal to next head and head equal to head next. We have to move the pointer to the next node. Free PTR. That's it. Delete last node from the linked list. This operation takes the following steps to delete the node. Traverse to the node of the node using the temp pointer and use another pointer previous which pointer previous node of the temp node. Temp pointer. Update the next pointer field of the previous to null. Free the memory of the temp pointer. Deleting the last node of the given list. Traverse the list at one node before the last node head. Okay, let the last node. I am traveling to last node. Now traverse the list at the one node before the last node. One node before the last node. Up to this one we need a travel. Update the next of the temp node to null. This one become a null and free the last node. This will become a null and free the last node of 18. Algorithm. If it equal to null, write on the flows. Go to the step 8. That's it. Exit. End of the list. Set PTR equal to head. Repeat step 4 and 5. While PTR dot next equal not equal to null. So pre PTR equal to PTR. Set PTR equal to PTR next end loop. This step should be repeated until next finding the next null. So set PTR, pre PTR next equal to null and the free PTR. That's it. So we need to maintain for deleting the two pointers. One is the PTR pointer and is the pre PTR pointer. So PTR pointer with the temporary pointers it will be moved. So here we also use two pointers PTR and pre-PTR to access the last node and the second last node. Delete the node after a given node in a given list. Delete a node at the given position leads to the following steps. Traverse the list to given position. Same logic in the inserting. Giving using the temp pointer and use the another previous pointer previous which is point to the previous node of the temp pointer. Update the next pointer of the previous to the next of the temp pointer. Free the memory of the temp pointer. Deleting the node at the position 3 in the given list. Traverse the list at the given position. Head previous temp. Okay. Update the next of the previous node to the next of the temp node. Now is pointing to here. So we are going to release this. Free the memory of the temp pointer. Now if you create this and with this pointer value will be go here. Delete after node. If head is equal to null, right? right? Go to step 10 end. Set PTR equal to head. Assign PTR, assign head to PTR. The PTR equal assign to PTR. Step 3, 5 and 6, while PTR next not equal to num. Then set PTR equal to assign to PTR. Next PTR, this one, and the end of the loop. So steps will be repeated 5 and 6 until reaching the positions, finding the positions. Set temp equal temp assigned to PTR. Pre PTR next, pre PTR next. Pre temp, that's it. Search. Finding an element is similar to the traversal operations. Instead of displaying data, we have to check whether the data matches with the item to find. Initialize PTR with the address of head. Now the PTR points to the first node of the linked list. A while loop is executed, which will compare data of each node with them. If the item has been founded, then the control goes to the last step. To find the node with the given key, we need to traverse a list from the start to end and match the data with the key. If the data is found in the list, then return 1. Otherwise, return 0. Initialize, set PTR. Initialize, set PTR, head. Repeat step 3 and 4. While PTR not equal to null. Okay, if item equal to PTR data, whatever the given item equal to PTR data, then position, she had position equal to PTR. Else, set this. Okay, set PTR equal to PTR next. So you have to repeat the steps 3 and 4. Then position equal to null. Position equal to null, PTR is not equal to null, exist. Update here node data. Updation is the process of change the given value of the node. To update the node data, we have to follow the given steps. Traverse a list from the start to the given position. Update the value of the node. So this is the algorithm for the linked list. Algorithm for the linked list. Okay. So anything, please comment in my comment box. It will be helpful for my future video development. Student, hope you understand the algorithms.